All right, hello everyone in calculus. I am out of town today, and so I made a really short video on the final piece of the chain rule that we've yet to cover. Just a reminder, any questions that you have over day 1 and day 2 of chain rule, we're going to go over Monday. But a lot of what you do today will help because you're going to work in groups, you're going to do a review guide, but first we're going to start with this, the chain rule when there's trig involved. I showed you a few examples with this, but we didn't really go in depth, so let's take a look at this. One thing you do to help yourself is you decide whether the trig part is the quote-unquote inside of the function or the outside of the function by putting in parentheses to help you. Okay? So, for example, number 1, find the derivative of each of the following. Sine squared x, we can't really tell what's inside, what's outside, but we need to rewrite this as the sine of x squared. Now we have very clearly a quantity squared. So following the chain rule then, we do the derivative of the outside piece, which the derivative of the outside, bring the exponent down front, the inside stays the same for now, and then subtract the exponent by 1, so we get this, 2 sine x, times the derivative of the inside. Well, the inside is sine of x, so we multiply that by the derivative, which is cosine. So my final answer is 2 sine cosine, but I'm going to be fancy here and remind you that that is an identity sine of 2x. Either of these are fine. I just want you to get the hang of looking for those identities. Okay, so you could have 2 sine cosine, or you could have sine of 2x. Okay, this one's a little different. Look at number 2. This one is sine of 2x, so the angle is the focus here. So when we do the derivative of the outside, what's the derivative of sine 2x? Well, that would be cosine of 2x times the derivative of the inside piece, which the derivative of the inside piece is just 2. So then our final answer, this 2 is being multiplied by that, so it's the cosine of 2x. Be careful not to make that 4x on the angle. This would not become a 4, okay? Because the angle is its own piece, so the 2 multiplies on the outside. Okay? So there's 2. Let's look at a little more of a complex one. This one, not only do we have a trig function with a 2 in there, but we also have an x squared in the front. So this is where we're going to have to use both the product rule and the chain rule, a product chain. Okay? Here's what I mean. To find this derivative, we're going to do the derivative of the first, which is x squared. Oh, 1 second, I have a phone call. I'm making a video over here, by the way. I'm not talking to myself, in case you were wondering. So we've got product rule. So here's part 1, and then here's part 2. So the derivative of the first is 2x times the second, which is cosine of 2x. So here's the derivative of the first times the second, plus the regular first. And now we're going to do the times the derivative of the second, and the derivative of the second includes a chain rule. So the derivative of cosine 2x is, derivative of the outside is sine 2x, negative, and the derivative of the inside is 2. So that's actually going to be negative 2 sine x squared. And notice how, all this is getting jumbled up. You never put the number after the variable. So let's go ahead and make this negative 2x squared. So I'm going to hit that again. I'm going to write it right here. I don't do this for every problem, but this is the derivative of the first times the second, plus this is the regular first, just this piece, is the regular first, times this in green, so this 2 along with this is the derivative of the second because it includes the chain rule. Okay? So then we can clean this answer up and we get 2x cosine of 2x minus 2x squared sine of 2x. If we really wanted to, which nothing's going to cancel, so we don't have to, but it's still a good habit. We could factor out a 2x and have a cosine of 2x minus x sine 2x. Either one of these would work as your derivative. Not only did you have the product rule, but you had the chain rule too. Okay, lastly, let's look at number 4. Sine of pi x divided by cosine of pi x. So this is going to be quotient rule, right? So let's go ahead and do the quotient rule here, which is the derivative of the first, so the derivative of sine of pi x, that's going to be a chain rule. We should do this off to the side. Let me pause this video for a second. I have visitors. Alright, I'm back. So you got to do a quotient rule. So derivative of the first, so the derivative of sine pi x is going to be derivative of the outside, so cosine pi x times the derivative of the inside, which is just pi. So that is your derivative of your first term. So we've got derivative of the first times the regular second. So this is going to get messy. Use parentheses to help yourself out. Minus the regular first times the derivative of the second. So the derivative of, I'm going to do that up at the top, derivative of cosine pi x would be negative pi sine pi x, using the chain rule. Okay? So we've got derivative of the first times the second minus the regular first now times the derivative of the second. And all of that is over the bottom squared. So let's say cosine pi x to the second power. Now we just need to simplify and we're done. So pi cosine pi x times cosine pi x would be pi cosine squared pi x minus, and actually these two negatives are going to turn into a plus, so plus pi sine squared pi x all over cosine squared pi x. And if I'm looking, I could factor out a pi, but nothing would cancel out, so it's not necessarily worth it. So you can just leave your answer like this. Okay? So to wrap things up in this video, when you're dealing with trig and you've got a chain rule, if it looks like this, where the trig function is squared, you need to rewrite it with parentheses like this, and then you can clearly see outside inside. Or if the angle is different than x, you need to remember that you do the derivative of the outside, which will be that, then multiply it by the derivative of the angle. So using these 4 examples in the notes at the top, you should be okay to do the homework practice. You can work in groups on that since I'm not here. And when you finish, then your only other assignment is to start the review guide, because we have a test on this on Monday. So work on the trig, and then when you've officially learned everything you need to learn for this unit, now it's just time to practice more and review. If you have questions, get them ready for me when I come back to class next week.